The third factor, I have two wires of same length and same area of cross section. The question is the resistance same? Well, they're made up of two different material. So now the question is again, is the resistance same? I won't tell the answer. Let's do it. So I'll take one copper wire and one lead, right? And we'll measure the resistance and see. Okay. So both the areas of cross section and length, they're the same. They don't look. You might when I show you the video, you guys will see that they don't look so, but they're almost the same length and area of cross section. So I have the lead and copper wire, same length and area of cross section. Okay. So let's measure the resistance. So in the background, I'm connecting those to the leads. Yeah. So it started to read and it's settling down. It's around 6. That's the resistance of that particular length of wire with that particular area of cross section. So the resistance happens to be 6. Now we'll connect the lead, okay, and we'll check the resistance of this. So okay, it's still connected. It's around 14 and 15. It's settling down at 14. So same area of cross section, same length, two different materials have different resistance. One is 6, another is 14. Is it not? So yes, we are looking at two different materials, and the conclusion is the resistance will be different for the same area of cross section and length but different material. Okay, we're not talking about will it increase or decrease. There's nothing increasing and decreasing. We're just talking about will it be different. So yes, it will be different. How will we fit this into the formula? Because we're not talking about proportionality. So how will we fit it into the formula? Right? Actually, it comes as proportionality constant. If you guys don't know about that, when you remove proportionality, we need a proportionality constant. So this is nothing but that unknown factor which adds up, basically multiplies. So measurable things. It depends on mainly on the material. Okay, the shape, structure, and the material and all of that. It depends on that. So that proportionality constant, when it comes to resistance, is known as resistivity. Okay. So resistivity, it's like like rate. It's like density with respect to total cost and mass. See, total cost of anything that you buy depends on the number of things you buy. So total cost is a total amount to pay, while rate is it's fixed, is it not? Right? Again, I'm trying to teach you guys the difference between resistance and resistivity. Okay, so let me be clear with that. This is like resistance, and these are like resistivity. So resistance are like total cost. It depends on the total length of the material, area of cross section, and all that. Resistivity is fixed. It's like a rate. Per unit you have a certain amount fixed, so that's why rate are rate. And total cost is it's always depends on the number of things you buy. It's like half a kg of sugar, right? 2 kg of sugar, but a kg of sugar is fixed. A kg of apple is fixed. Kg of guava is fixed. Is it not? Similarly, density of a material is fixed. It's always per unit volume, right? But the mass depends on how much you are taking up, right? Density of gold is of certain amount, but no one buys 1 kg of gold all the time. Okay, I mean, if they do buy 1 kg, it's a huge thing, but no one will do that, is it not? So they'll buy in different grams, or in some cases maybe a kilo or more than a kilo and stuff like that, is it not? So, but density is fixed. The idea of density and the measurement of a density of a material is fixed. Similarly, resistance depends on how long a wire is. Copper wire. right? If you want to find the resistance like I just did now, just connect the multimeter and you're done. While resistivity, it's always has to be of ideal shape, of unit cross sectional area and unit length. Okay, so it's always that. So let me show it to you guys. Just a second. So here I have a wire. Okay, out of this, I will cut out a unit long and with unit area of cross section. I cut on a material out of it and I place it in front of you guys. So let me do that. Right, I'm cutting out a unit length of material with unit cross section. So the area of this is 1 unit square. Okay, and the length is 1. Okay, the length is this way, but anyways, end of it, it's a cube that you're looking at. So it's the resistance of this particular cube, whatever the material may be. It's the resistance of this which is equal to the resistivity. Okay, so we'll be talking about resistance and resistivity in terms of formula also, but I hope you guys understood. It's nothing but whenever they ask, whatever they ask, resistance depends on the length, right? Like this material, I can change the resistance. How? Just increase the length or decrease the length. But resistivity of this material is always this. You can't touch this. This is fixed. Okay. Resistivity is always fixed while the resistance can vary. Remember that. And this is the proportionality constant that comes out when you derive the formula. So this is your third factor. So till now we have seen 3 factors: area, length, right? And the third one happens to be resistivity. Okay. So next step is to derive the formula out of all of these 3 factors.